Okay, so my name's Adam Weeks. I'm an instructor for EMC. I'm one of the Isilon instructors. I teach all the Isilon classes. I've had a few newer instructors saying that they're finding it difficult to do the multi-protocol, and they find it hard to understand the multi-protocol. So I thought I'd put together a video explaining and demonstrating how multi-protocol works right from the beginning through to actually demonstrating some of the problems you can have with multi-protocol and that customers would typically have, and some explanations around that really. I've worked with NAS devices for a long time, so I've worked with NetApp, used to work for NetApp, and then I've worked with Solera, so there are a lot of commonalities in the problems that you see with multi-protocol. Isilon's not unique for that, but it is quite tricky to understand the inner workings of what the cluster's actually doing. So the aim here is to describe exactly how multi-protocol is working and, as I say, demonstrate it. Some of the things I'm going to talk about are fairly rudimentary to this. You may already understand them, and that's fine, but I'm just going to start right at the beginning before we get deeper into exactly how it works. Okay. So the first thing to explain here is how the very basics of how Windows and Unix works. There's actually quite a lot in common in the way they do things. So when you access a file, in Unix you have Unix style permissions. These are POSIX mode bits, which is just a fancy term for them. And POSIX mode bits will give you this read, write, execute style of permission. And of course, fairly straightforward on the read, I can read the file. Write, I can write to the file. Write would include deleting as well. Execute, if it's a binary or a script, I can run it. If it's a directory, I can list it. So it's just the permissions that I have. These would apply to three different groups. So you've got the owner or user group, and then other. So you've got three different areas they apply. Owner or user, it's your file, what can you do with it? And usually there'd be fairly open permissions. Group, it's not your file, but usually the owner of the file is in the same working group as you. So you might both be in the engineering team, and that will be mapped into the permissions within Unix. So if you're part of the same team, you might say, well, you can't write to my file, but you can read from it, because you might need that information. And then everyone else is a constant of, well, it's not your file, you're not the owner or in the same primary group or the same group, so this is the permissions that kind of everyone else gets. It's actually quite straightforward. Underneath, of course, Unix is using different identifiers here, so the identifier here will really be your user ID, and your identifier here will be your group ID. And these are two different numbers that Unix is using. They're 32-bit numbers, the same format for both of those, so they have to be stored separately because otherwise it'd be very confusing which is which. There's no differentiator in the format because it is just a number. So they have to be stored separately for that. The other thing, of course, is people don't generally like to remember from the class before. People generally don't like to remember numbers, especially when they're big numbers. It's much easier to remember a name. So these would normally be resolved to a name instead. So these would normally be resolved in some way to a username which would correspond to you or to somebody else. And of course, same for a group. People don't really remember their group ID. They don't really want to have to remember group numbers. So a bit like why you have in your phone, you don't really remember phone numbers anymore. Instead, what you would do is to remember names. You tap into your phone book, I'm looking for this name, give them a call. You never really remember the number anymore. Same thing here. There are different ways that we could get this user ID and group ID. If I quickly show you on the desktop, the traditional way is from a local file called the password file, which used to contain the password and doesn't anymore. So here, if I log in as Martin. Let's go to the temp directory, doesn't really matter where we go. There's a few files in there. Okay, let's ignore it. Let's make an empty directory. Test under temp, cd test. Nothing in this directory at the moment. Let's touch a file. It's called file.txt. If we do an ls-l on there, show me the file. You can see here this file belongs to Martin. Martin is, so the user in question here for the first set of permissions is Martin. Martin's permissions are read and write to the file, but not execute. And you can see here, if I just highlight here with the mouse, I can't over here. Down here, you can also see, so Martin is here, has read and write. The group in question here is the users group, and you can see the users over here. Users get read permission. Everyone else, there's no reference to that, is read only. That's how we would see that file, but the system would do it slightly differently. It would be more concerned with these. In this case, the user ID is 2003, which just happens to be Martin's user ID, and Martin's group ID there for the users is 100. So if I want to, I can see that, but you can see there's a difference there between the two systems. If I show you the password file here, cat/, there won't be an entry for Martin because it's not using it, but this is what the file would look like. And you can see here, this is just a file to resolve user IDs to usernames plus some other user details. So if we look here, look at root. So you can see the root is a username, which is a standard Unix user. X is where the password used to go in an encrypted format. It's not there anymore, it's in the shadow file, which is where the password file gets its name from. You can see here the user ID for root is 0, and then the group ID is also 0. Then you get a description of the user, home directory of the user, and the last part there is just the shell, the style of command line that the user likes, or tends to use. So this file will be stored locally on different systems. The big problem with that would be doesn't scale very well. If you try to store that file on lots and lots of different PCs, that gets difficult. So we don't always do it that way, and I'll go through some of the different directory services. But you can see here how permissions works in a Unix system in a very, very quick way. Windows is not that different. Under Windows, you get access control lists. Essentially, you get a more complex set of permissions where you'll have lines with a different an account for a user or a group, and then next to it you'll have the permissions that user or group can or cannot do. And they can be a lot more complicated because you don't have these set 3 places you can set permissions. You have as many as you want, really. You can have multiple sets of permissions, and I'll quickly show you that in the lab because it'll probably make more sense. Let me fire up my Windows client and server. So wait for that to fire up, and then I'll send it my Control-Delete. Yeah, because it's more complicated and a much more complex list, it's probably easier just to show those permissions. Usually to a student, of course, more familiar as well. Most students don't understand the Unix side as well as they understand the Windows side. But I'll just show you that underneath they're very, very similar. So let's log in. OneFS administrator, and let's pop open so if I just go into my downloads folder, let's make a file here, new text document. So just like with Unix, I've created a file. Now if I go to my permissions, they're here. And notice underneath that I've got my account, I'm administrator. My permissions for that file, which is, you see down here, is allow for full control, modify, read, execute, read, write. There's then the group, they look very similar there, the group for administrators in general, same permissions on there. Of course, because I'm an administrator, I've just created a file, pretty open permissions on there. But the big difference here is I could add somebody to that list if I wanted to. So I could say, what domain server not up? No. You little bastard. Hold on a second, let me go around. My domain control I don't think was up. Sorry, I was on the Windows client, brilliant. No, I don't. Just sign in as Martin then. Right, so if I go into my Windows client here, and I just, let's just go to the local drive, go into my downloads. Let's create a file just like we did before. So let's make a text document. Martin's file. If I then go to properties of that file, you'll see the permissions look slightly different. I've got my access control list here. I can see that each person gets their own entry. So here I've got Martin Multiprotocol. And you can see the permissions underneath. There's a group for administrators. Administrators by default here getting open access to other people's files. If I wanted to here, I could add in another user. Who have I got? So I've got William here. I can then say, okay, I want to give William access to my file. I want him to be able to read but not write to my file, which is a default here. I could say don't execute either and say OK to that. Oh, excuse me. When I then look at the properties, you can see here I've just added another permission in, just more advanced really. I could keep doing this, add various groups into there. Big difference here as well is that the identifier underneath is an SID. It's a longer string, which means it can differentiate itself from being a user or a group. So here if I do a, let's go into command line. You see that I'm Martin here. if I look for my SID underneath, you can see here I have this long string just here that is identifying who Martin is. That's how Windows sees that user. You can also ask a question, so why do we need an SID underneath or a UID in Unix? Well, don't forget that usernames can change. So if I go in here and change Martin's username, I wouldn't have to change any permissions underneath, because Windows kind of says, well, I'm not really using that anyway. I'm just allocating that SID with all the permissions and resolving the username. The same in Unix. If I change your username, you'd still have the same user ID. So I don't need, we've got this two levels of identifier for that exact reason, that I can change one without affecting the other. And of course, I tend to see it more as the named ones are for humans, these underlying IDs are for systems. That's what they're really using. You can also see from a high level, they're actually quite similar in what you're doing. You're using an identifier and you're using permissions. Identifier is to identify who you're referring to in the permissions, whether it's Unix or Windows. And then the permissions identifies what you can and can't do with that file. And of course, an enterprise system is very important because, let's say this was a directory for everyone's home directories, you wouldn't want everybody to be able to access your home directory, and you would want control over that. But then you might have shares that are for multiple users, and you might want different permissions for that. So it gives you complete control over who can access what, really. So that's kind of very high level what these identifiers are for, and from a high level how they work. I'll also kind of explain why this is tricky as well. So if we start to look at how single protocol works on Isilon, it's not actually that different from what we've just seen on a Windows and a Linux system. So let's say you store a file. Let's call this file.win. You're going to store that on, that was stored by a Windows client. Let me change my pen color back. When a Windows client accesses, it will use a Windows-based protocol, so it uses SMB. When it's using SMB command set will specify that it wants to see SIDs, because that's how Windows works. So when it stores the file, and this is all defaults on Isilon at the moment, I'm not going to talk about any changes at the moment, but by default, what Isilon will do is to say, okay, that Windows client is talking to you using SMB. SMB commands are sending me identifiers here, which is the underlying SID. I'm going to use that. So when it's writing it's ID there really. When I'm using the identifier, I'm using SIDs because that's exactly how Windows would do it. When I write my permissions, I use Windows style ACLs that we've just seen, access control lists. The permissions, which of course doesn't really look any different from what we've just seen. Single protocol on Isilon is very, very straightforward. That Windows client, when it tries to read the permissions off that file, it will not really see any difference. And I can quickly demonstrate that on the system. So here, rather than writing locally, let's look at the cluster here, which is just a share from the cluster. If I go into data, file there already from Martin, but I said write new file. What I call this file.win. Windows will probably get upset if I call it that note. This is on Isilon, on the virtual node. If I go to security on there, doesn't really look particularly different, does it? To the client and to the end user, nothing strange going on here. If I do this slightly differently now, we do it the other way around, so we talk about Linux. if you try to write a file, let's call it file.nix using Linux. Let me draw my Linux client here. Of course, when I say Linux, could be Unix, could be any Unix-like OS, doesn't really matter. It will use, for our examples, let's say NFS3, so traditional NFS. NFS3 being Unix-based will use POSIX mode bits for permissions. It will use UID and group ID for identifier. And just like before, nothing different here, same as native. So here it's going to say, okay, for the ID, let me use UID. Of course, we also have the separate group ID now, which is just how it works in Unix-based systems. They're stored as two separate values. We only have one type of value in Windows, the SID. Then for the permissions, perms, this will be POSIX mode bits again, which is just the fancy term for those Unix style permissions, read, write, execute style permissions. And again, I'll show that if we log in through the Linux client. Only this time we'll make sure that we access the cluster, so ls, not mounted at the moment. What's that mounted? Should auto mount, I don't know why it hasn't, but let's go in. Let's do slash. Okay. Let's log in as Martin again. G/IFS/ data. Oh, sorry. CD /Isilon mount point CD data. So in the same directory as before. Ignore the fact we can see those files, but let's touch. What do I call this file? File.nix. If I look at that file, that doesn't look weird. It's not unless you're not familiar with Unix, but yeah, nothing odd about that because it is doing everything natively that Linux would do. It's saying, yeah, I'm looking at the permissions using read, write, execute, just like before. So I can see here I've got my permissions on there. These are just normal permissions stored in the same way as Linux. And then over here I've got my user and I've got my group. If I do if I look underneath, Martin happens to have a user ID of 2003. The group ID for users is 100. Don't worry too much about how it knows that, but at the moment, let's just say pretty normal. So single protocol on Isilon is actually very, very easy. It's not much to it. Of course, if we look at my diagram, what's tough is if you then say, well, okay, a feature of Isilon which does work is I can do that or I can do that. This is where things suddenly get a bit more complicated. The problem here, of course, is the same for any NAS device that can do this. So the solution may be slightly different, but NetApp would have the same problems and have their solutions. Unity would have the same, Unity file, of course, would have the same problems, just different solutions to how they fix those problems. The problems are quite straightforward. Here I have my Windows client, and it's trying to look at file.nix, but it doesn't understand what UIDs or GIDs are. It doesn't use them, even though it uses something similar, SIDs, different format, same concept, and it also uses permissions, only it uses ACLs that are a different format, same concept. So it doesn't directly understand that file.nix. Linux is, on the other hand, if it tries to look at that file win, you've already seen in the demonstration there, just on the computer, you can see the other files from the Windows side on the Linux side, but there has to be some magic there, because when you look at the file you say, but I don't understand SIDs, I don't use them, I use UIDs and GIDs, same concept, different format. When I look at the permissions, I don't really understand ACLs. I do use permissions, but they have a completely different format and work completely differently. And that's where we're getting our problems here. This is where things get a bit more complicated in the way they work. But yeah, the complication comes from, even when Unix and Windows do the same things, they have to do it slightly differently. So this is where we're getting a bit more detail on how they do this, how they would handle this. Okay, so the first thing I'll describe here is just, before we go further in, I'll try and draw out the environment that we have, just to explain the lab setup in a bit more detail. So you can see here I have cluster, which is a single node cluster. As instructors, you all know that wouldn't be normal. The simulator allows you to do that, and I'm trying to be as lazy as possible by not creating a full cluster. We don't need it for this lab anyway. Plus it uses less resource on the ESXi host, so it runs a little bit quicker. We then have a Linux client, which you've seen, just using that as a client machine so we can log in and see things. It's just running CLI version of CentOS. File server there, just in case we want to look at the differences between a normal file server, how that looks, versus Isilon. We have an OpenLDAP server, so that is our authentication, and I'll quickly whiteboard that in a second. From the Unix side, we have a Windows client, client access, but this time from Windows. You've briefly seen that in that demonstration. And then we have a Windows server, which is our Active Directory and DNS server. I'm also using that as a file server so I can briefly show you the similarities between a normal file server and Isilon. The point of Isilon is when it's presenting itself, it does look like a normal file server. And just to explain very briefly how we set this up. So if I do my authentication services in blue, we have LDAP, which is in my case OpenLDAP. This is being used for authentication for and identification for the Linux side. So what it's providing there is resolution from, well, firstly, when you try to log in, it will provide authentication. So it will check, do you know your password? Once you log in, it's doing the assignment of the UIDs and GIDs. And the reason I've done this in this demonstration is simply that's how most customers I've seen would do it. Not necessarily OpenLDAP, but on the Unix side, LDAP usually is the most popular way of providing identity. On the other side, we've got AD doing the same things for Windows. And again, why have we chosen that for the demonstration? Because it's the most common way of doing authentication in Windows environments by far. We'll talk about some other ways of doing this and how Isilon would handle that. But yeah, these are the two we're using in the lab. Yeah. Other providers we're not using, I'll quickly do in red, just to explain what else we support. We could do this with, we're not using NIS, but we could do it with NIS. NIS is a bit more old-fashioned, not as scalable as LDAP, not as advanced as LDAP, so not as popular. We've just seen the local password file. not very popular because it's hard to configure. You'd have to copy the file to multiple systems. It's not centralized management, so it can have some performance benefits in certain situations by not having to go over the network to look up users, but not very common in anything but fairly small environments. On the Windows side, we could use local users. We can also have local users stored directly on the Isilon for Unix users. But this is what we've done in the lab, so we have this authentication. Let me write in the host names just to make this clear. So here, this is our Linux server. Brackets, that's how we're doing it in the lab. AD, of course, is our Windows server. And they're named, obviously, to make life as easy as possible. So that's what our two servers are. Cluster is the Isilon. I can't show you, sorry, I'm not using this whiteboard. Let me just do that in black, actually. Which, of course, I'll draw it as 3 nodes. It's not 3 nodes. It should be in a real cluster, but the cluster in our case is just a single node Isilon. And then on the client side, we've just got Win client. The clients are both running, client and server are both running Windows 2012 R2. And then we've got Linux client, which is, on the Linux side particularly doesn't really make much of a difference, but the Linux servers are running CentOS. So that's a brief view of how authentication is working. As I say, the file server is just there for demonstration purposes for the Linux file server, or for, the Windows server is also acting as a file server, just so I can show the similarities. The first problem we come across, just going back to here, firstly let's talk about permissions and how Isilon will handle those permissions, because clearly, as we said, Windows will not understand those permissions. Linux won't understand those permissions. So the first thing it needs to do is, or one of the things it needs to do is, we need to define how we're going to handle that situation. What do we tell Linux when it looks at that file.win? What do we tell Win when it looks at that file.nix? On Isilon, it's fairly straightforward. They've chosen a very simple approach, which is you translate the permissions for the other OS. So if I quickly look on my files, let's go to my Linux client again. Can't remember what I call my Windows file. I think it was the file.win there. Miraculously, it can see that file. I'll explain a bit more of what's going on, of course, but it can see that file. If I do the same thing the other way around, so it looks normal to Linux, which is weird because that shouldn't work, but it shouldn't work in the big picture sense, but of course Isilon's doing the translation for those permissions. If I go to my Windows client and try and look the other way around, notice how I can see all the files, file.nix is there. If I go to properties, doesn't look strange to Windows. It's saying, yeah, I understand the permissions for this file because they're being translated. They shouldn't make sense, but they do because they're being translated on the fly for Windows. In this case, when this happens, we describe this as a synthetic ACL. So the ACL that's been created for Windows is only being created in memory as a one-off operation. If you access the file again, you'll have to regenerate the permissions again. So this is called I'll put terms in blue here. So when it does this, this is a synthetic ACL, because of course, ACL, because it's not real. It's just been generated on the fly. We saw as well, when you go to Windows and you look at the file.nix, it doesn't have a name, but it's generating those permissions on the fly by translating them. We can also demonstrate that by saying, okay, what does this actually look like underneath? We can look at the real permissions on the cluster. I go directly into the cluster here. Do I have that open? No, I don't have it open at the moment, sorry. So I can see my files, which of course we're on the cluster now, so it would be able to. If I do a full listing on there, saying, yep, I understand how these work. We'll talk about how, ignore the identities for the moment, we'll talk about that next, but we can ask it, well, how exactly have you stored that with the extra command E there, which will show us the real permissions. That's quite a lot there. Let me just do that on one file. File that I can't remember the name of. Let's say file.nix, which of course that came from the Linux client. So it says, yeah, it's the permissions here are the real Linux, Unix style permissions. They're the normal Unix style permissions over here. So I've got read write for the owner, for the group I've only got read, for everyone else read only. It's then saying, okay, so who's the owner? It's recognized that it's a Windows user here, so I'll explain later on how it's a different subject, but it's using the same structure as it normally would if that was a normal Unix user. It's then saying, okay, for the group, I've got the group here of users, so let's find that. That actually came from OpenLDAP. Notice here it's saying it's a synthetic ACL. It's saying it's not a real ACL. I made this ACL up by looking at the permissions and translating them, so none of this is being stored underneath. It was generated on the fly, and it's saying, okay, so you've got the user, there's the user, and I'm saying allow file generic read, file generic write, standard write, read and write. it's basically the translation of read and write permissions for that user in Windows. So the ACL has been written based on those permissions up here. The second one is a group. It's saying users allow file generic read, just like that, for the group users, which is the OpenLDAP group. And then down here it's saying everyone else read, same as here. So you can see translated, but from the Windows synthetic ACL has been made from the Unix permissions. And let's ignore the IDs, that comes next. You can talk about that in a second. If we go back to the Windows client, oh, sorry, what am I doing? Don't want to see the client, we want to see the files, don't we? If I do my, well, first of all, I think I showed this before, but let's do an ls, let's do a long listing on file.win. Which is odd, because of course this is where this file has an ACL on it and an SID. SID will cover in a second. Notice a couple of things here. First off, there's a little plus. This is an indication there's a real ACL on the file, also known as an advanced ACL. Then it's saying, okay, so I'm actually translating these permissions from the ACL. So I'm saying you get read, write, execute permissions, and that is for the owner, who is Martin. Nobody else here gets any permissions. Okay. And the group it's referring to is domain users, but there aren't any permissions assigned to that. So that's coming from the Windows side. If we do the same as before and we say, okay, let's do a, why don't I delete the rest of that? File.win. Let's see what the real permissions are. And it says, sure, I'll show you the real permissions. This time around, the Unix permissions or the POSIX mode bits aren't real. So these are being made up for the sake of showing the file. Underneath it says, okay, so the real permissions here are coming from the ACL, and the real ACL says, okay, the owner of the file is Martin, group is domain users. For the user, the only permissions we get here, the only permission in the ACL is Martin has allow file generic all, which is shorthand really in Windows for read, write, execute permissions. So there's a real ACL there which came from Windows. If I show that from the Windows client, where is it? There. Yeah, you can see here. I'll talk about some of the subtle differences here, but yeah, that's basically saying there are your permissions, file generic read, write, execute on that file, but nobody else is there. It's only Martin. So you can see those permissions are based on the permissions we're seeing in Windows. Okay, file gen all. Yeah, there's nobody else in that ACL. So that's the first thing it's doing. It's translating on the fly, so those permissions are being shown. I'll show you a bit further on. There are some other advanced things going on, and there are reasons why there are some other advanced. There's some controls in place for how those permissions are being translated, and they're there for a good reason. They're there for troubleshooting type reasons. The next thing is, okay, so what about these IDs? So permissions are being translated. We've seen that. It's predictable how it does a translation on there, so it's easy to determine how this permission should look. But here, when I say, okay, sorry, on that point, when we do the ACL to Linux, those translations are based on white papers from NFS4. So in NFS4, there is a possibility of seeing files with ACLs on from clients that don't understand ACLs. So when they wrote the white papers for NFS4, where they wanted Windows and Unix style clients to interoperate and use one file access protocol, they tend to standardize on ACLs, but they understand that in some cases there might be an OS that doesn't understand ACLs and may need to translate the ACL into POSIX mode bits. So there are kind of agreed standards on how to do that. They're not entirely agreed, but that's the closest we've got. You know, when they wrote those RFCs, it was a case of that was kind of an agreement on this is how you do the translation. In our documentation, we show exactly how we translate that. So for a customer, they can see exactly how that should be translated. Okay. Yeah, the next part is the IDs. The IDs is a little trickier. So the problem here is pretty much the same as before, but we can't do a translation this time exactly. Here we're going to say, okay, Windows is going to look at this file.nix file. It's not going to understand UIDs and GIDs. It wants to see an SID, needs to see an SID really. How do we know which SID to use? And the same the other way around, this Linux client looks at this file.win, and it says, I don't understand SIDs. I'm expecting to see, as we've just seen, Unix style permissions, POSIX mode bits, but also I want to see UIDs and GIDs attached to those Unix permissions that I see on different files. This is where it gets fairly complicated because, let's be fair, it's complicated on any NAS system how you do this. The same for the permissions. We do approach it differently on different platforms. It's not always the same, but it's never going to be very simple to do this. So let's start with the very high-level way that we do this. The way that Isilon does this is to create and use what they call an access token. An access token contains several details, so it's finally created. It contains several details within the access token. The primary thing we're interested in right now is the UID, group ID to SID mappings. So it's cheating to say this, but it gets it from memory, where it gets its access token. Of course, there's a bigger question here of where does the access token come from? How does it generate that? But for the moment, let's say it's just there. We're always going to know one of these values. We're always either going to know the user ID and GID, or we're going to know the SID because you had to have come in through a client. So the first time the cluster sees you would normally be you've accessed a share or an export. So in our lab example there, as soon as we mounted and went in as Martin to look under Linux, it said, well, okay, I've seen you now. When we went in through Windows as Martin, it said, I see you now, I'm going to generate your access token. It does the work up front of trying to find your different identities and combine them. So let's say we came in from Windows. We'd know your SID. How would we know your SID? You came from Windows. Your Windows client told us your SID, as it normally would do. If we were a Windows server, it would do the same thing. When I then look at the file here, because you're the Windows client in this case going to the file.nix, it says, well, okay, now I know your UID and GID. I can work out the permissions of how I should show you those permissions. It does need to have the identity there, otherwise it wouldn't know how to translate the permissions. It needs to know who you are. The access token does contain other things, but let's keep, again, we'll add to this, but let's keep it simple for the moment. If we do this the other way around, you came in through Unix, it would need to know your SID if you were looking at the file.win. So it's the same thing the other way around. We need the other identity is the main thing we're interested in this example. Of course, the big question there is, okay then, how does it assemble the access token? And it's a fairly complicated process. The first thing it will do here is to say, I know one of your IDs, I want all of your other IDs. This is where we use the ID mapper process to try and find your other IDs. It's interested in, if I know one of your IDs, how do I find the others? And the search order we do this in is, the first place we're going to check is Active Directory. And we're looking for services for Unix /IDMU. So my example here, we know your SID. I can look you up in AD quite easily. Don't know your UID and group ID. Active Directory has features where you can store Unix credentials within Active Directory. And the logic behind it is, if you think back to 2000, Microsoft were competing for the server space. They were more of a desktop OS at that time. They're trying to expand into the enterprise. They were using Active Directory to do that, and Unix was the main OS on the server side. It made absolute sense to say, let's be as compatible as we can and friendly as we can with Unix so that we can get Active Directory in there over time, try to push Unix out, really. So it's a case of being compatible was a good thing. It meant Active Directory was usable in more environments. So it's, Microsoft's way of doing that made sense. They are standard features of Active Directory. The huge benefit here for us would be, let's imagine an administrator's configured this. This really means somehow the administrator is specifying every single user's UID and GID, which means we're not having to find it any other way. There's not much scope for a mistake there. So it's the preferred way of doing this. Let Active Directory tell us the user ID and group ID of the user. If it's there, it's what's first in the list, it's very much preferable. If it's not there, the next place we would normally check here is the ID mapping database. This is an internal database within OneFS, and its job is to look for one-way mappings between UIDs or GIDs and SIDs. So you'd see in here SID to UID mappings. In our case, that's what we're more interested in. And UID to SID mappings. So they're all one way. They are editable as well. And yeah, if there's an entry there, This is a nice easy way. It will just specify, okay, I've seen this SID and it maps to this UID, if we're lucky enough to see it there. Quite commonly though, there may not be an entry for a user within that database. This system does write into that, so it's typically almost like a caching mechanism of, if I've found a UID in the past in certain ways, I want to remember it, I don't want to lose that mapping, it would write it to the database. We are going to see it do that in a second. The next way, if this fails, and there's a reasonable chance it would at this point, yes, hasn't found the user yet, the next thing it will do is to look through different services to try and match the username. So I'll do it on a username match, which I'd call a search here through local provider, file, local file, LDAP, NIS, LDAP. Of course, that's something that's in common between Unix and Windows. They do both use usernames. So it's taking a guess here, taking a punt that if I see that Martin and I see in Windows, I know the username is Martin, and then I see Martin in LDAP, it will say that's probably the same person. So it's making that assumption. We'll talk about problems and troubleshooting, because of course that could be wrong, but that's what it'll do by default. If it matches up the username, in our example, that would have come from LDAP. That should have come from LDAP if it's working properly. So it should have come from LDAP in there. Of course, if that doesn't work, we're in trouble. We don't really have another way. Where else do we look now? That's all our services where we would find or hope to find the user's real identity. So what it will do last is to allocate the user an identity. You think, what do we mean by allocate? Well, we didn't find a real UID for the user. We're going to give the user a UID. At this point, it's kind of an assumption of this user probably doesn't have a real UID. So what are we doing? Well, let's just give them a UID. We're going to assign a really high UID as well. So by default, OneFS will assign 1 million to the first user it assigns. It will remember it permanently. So if this is the first time this user's been allocated a UID, sorry, this is the first user who's been allocated a UID, they'll get 1 million. Seems a bit odd, you know, why such a big number? Because we're guessing here that probably isn't a real UID. You know, customers probably doesn't have roughly 1 million users. So yeah, this is a fairly safe bet that this is not a real UID. There's nobody with that UID elsewhere. So we allocate them 1 million. The next thing we do is write that into the database. So this would be a SID to UID mapping. Yeah. Actually write that to both. We're going to permanently remember this. So this is now being permanently allocated by default to this particular user because we didn't find a UID on there. This is very automated, of course, in the way it does this. If we do it the other way round, if the system knows the UID and or GID, first thing is, if it only sees a Unix user, it doesn't by default generate the full access token. And the logic behind that is, by default, OneFS has a slight preference towards using UIDs and GIDs. Why does it do that? Performance. It's based around high-performance Unix applications, so it won't bother to do the resolution in a way. If it needs to do this, so by default it won't, if it needs to do this, it does very similar actions to find the user. The main difference would be when it gets down to the allocate stage, firstly it can check AD because it can look for a UID or a username in Active Directory. It will check the user mapping, so the ID mapping database. It will do a search through the providers, only the providers it will find an SID in though. So it'll only look through providers it knows, like local provider could have an SID. I think that's all, yeah, it'd only be the local provider would have them. The allocate is completely different though in the way it allocates. It does something slightly unusual. So what it'll do is allocate the user an SID, kind of a well-known SID. So let me do another color here as well. What it'll do is to say, let me give the user, so an SID's format is made up of numbers, the beginning part of an SID indicates, well, the S is it's an SID. The next part is indicating what the SID is identifying. Is it a user or a group? In our case, it can identify other things, but in our case, is it a user or a group? The last part on here will contain a reference to the domain and the user. So there are algorithms in Windows that will ensure that's a unique ID. But they call the last part of this the RID, the relative identifier, which is a Microsoft thing. This is to identify the end user, basically. And that will be unique to each end user. The clever part here is we say, well, yeah, user IDs should be unique to every user. In a normal environment, you would have a user ID, nobody else would have that user ID. So why don't we just put the UID on the end of an SID? We say, okay, this needs to be unique. So instead of having the Microsoft way of doing it, let's just stick the UID onto the end of that SID. So that's how we'd allocate for this way round. When we know the UID, we don't know the SID. We've gotten to this point. We have to give the user a SID in this point. There's a couple of differences here. One is we give it a strange name. We call this a Unix SID. You think, why is it called a Unix SID? It's just our terminology for it's an SID based on the Unix identity. So it's a weird term that we use in OneFS for that. The other thing is, notice that we don't need to place it in the database. Simple reason for that is if we see this SID again, OneFS will recognize that the beginning part here, the format is not standard, it's not normal. It'll recognize this doesn't look right, and it'll say, I know what's happened here. That's one that I've allocated. If I strip the beginning off the SID, I know the end part will just be the UID. So it doesn't need to be stored in the same way. Quite a lot going on. That's how it finds these different IDs. There's a confusing process as well here, where this would be, what we've seen so far would be referred to as ID mapping. We're looking at different IDs and mapping them across different providers. So we're mapping the UID in the first case to the SID in the first case to a UID. The second time around, we mapped a UID to an SID. The next step is a tricky part, where they call it user mapping. User mapping is the process of placing that all into the access token. So a single access token that can identify across Unix and Windows. It will have both of your identities in our lab example. It would also have some other things in, like, what about your groups? Which is your primary group? Which other groups are you a member of? Because that will affect permissions. So that's another thing that would be within that access token. You're assuming you have RBAC controls and you're an administrator, it could have your privileges in there. So this could also contain your privileges within the access token. So there's some other stuff that goes on in that user mapping process. But the user mapping is the process of building that access token. In some ways, ID mapping is a bit simpler. It's more of a, I want to look at the ID, map it to the other ID that you'd have. So a UID to an SID to a UID. That is part of building the access token, but the other things like putting the groups into the access token is the user mapping part. That's why it happens afterwards. Okay. I'll show this in action as well. I have to show you a bit more in the lab about the users that we have. So, let's take a look in our Windows client. Actually, look at the Windows server, will make more sense. Let's wake up our Windows server. Let's take a look at our domain users. I've tried to give them obvious names. Excuse me. So if I go to my administration tools, if I scroll down and find my users, I've got Martin Multiprotocol here. You see, I've used the names to help me remember which is which. So notice how Martin does have an identity within Active Directory. And then I've got William Windows down here. So I've got two users here. If I go back, to my providers here, let me just make a note of those. We do that in red. So here under AD, actually I think this is just William as a username, isn't it? Yeah, so this is William. And I think Martin is just Martin, let's be absolutely sure. Yeah, so you have Martin. And the domain is just, I'll put it in red, it's up here. The domain is Isilon MP for multiprotocol.com. So this is my user details from AD. If I then look at my Windows client, just the LDAP server has a GUI front end in PHP, so we can have a quick look at what's going on in there. Doesn't really matter who I log in as. Oh. So if we go into our, I have to log in first. If I then look down, you can see here I've got Martin Multiprotocol, who is Martin. Oh, sorry, just to give this as well, this is the LDAP domain is Isilon LDAP.com, so it's got a different name. Under here we have Martin. Notice how we don't have William. William is a Windows only user. You can't see it from here, but down here there is no William there. But we do have Larry Linux down here, who of course is a Linux only user. So we have Larry as well. Okay. If we've already seen briefly what happened with the ID, so let's have another quick look at that. If I'm in Windows, here I am Martin. If Yes, I see it on there, but I'll do it anyway. Who am I? Martin. I can see my SID there just in case we need to refer to that later. And of course, Martin wrote that file in Windows. If I go in, I can see the permissions there. See, it is the notice that is Martin at Isilon MP, so that did come from the Windows domain, which is as expected. If I look at file.nix, which is also written by Martin, that maps to Martin as well. So notice here how that does tie together. Partly because it's configured correctly, but that does tie together. If we then go to the cluster and say, okay, why did that happen when we wrote those files? Also, let's do the same again, just from the Isilon side. Oh, sorry, the Linux side, excuse me. File.nix, if we look at that, we can see there that was written by Martin, who is the Unix user. You don't see the domain in there, but that's a Unix thing. It doesn't show you the domain. So the user there is Martin, the group is users. That was resolved from, of course, for Unix, it came from OpenLDAP because it was written on a Unix client. If we then look at the file.win, notice how that also maps to the same user. So although we wrote that file in Windows, it was mapped to Martin. Notice how the group ID though is a bit strange. So 1,000,001. This is where we have the same problem here for the group ID. The system said, okay, I see a group in Windows. Can I see a matching group name in, sorry, yeah, the Windows group name. When I went to the Unix side, it said, well, okay, where's the group ID for that group? It went through this process and it said, I didn't find a matching group. It'd normally be by name that it would do that search. So it just allocated one. It said, okay, I'll give you group ID 1,000,001. There would have already been a group ID 1,000,000. So very, very similar concept in the way it's done that. Of course, the real detail now is, okay, let's look at what's going on in the cluster. First off, though, let's get Martin. We already saw this in LDAP, so you see how this is coming from the OpenLDAP server, but Martin's ID there is 2003 for the user ID. Group ID, there's a standard one, users, which is group ID 100. This is the one that couldn't find the exact name in Windows for users. So I've got these open here just in case we need to refer back to them. If we go back to the cluster, let's do it. Hey. Sorry, that's my mistyping. Isilon send directory. If we do an ls-le on the cluster, this is showing me what's really going on underneath. If I do this on file.win, you can see here how it's resolved the user to, well, it came from Windows, so Isilon MP Martin, so this is coming from Active Directory, which makes sense because it was written from Windows. It just said, fine, I'll use your SID. That's what it'll do by default. If I then look at the file.nix, slightly different here because it's saying again, okay, the identifier it recognizes is Isilon MP/Martin. So notice here it does know that this is the Windows account for Martin. And the big difference here is when we looked at this in Linux, Linux wouldn't understand that. So it just says, no, it's, oh, where was Linux? Linux client, excuse me. When we look at the file up here, it says, well, Linux wouldn't really understand that. So we'll just tell Linux, no, it's Martin, which is the Linux account. And yeah, we use this different group ID which it didn't find a name for, so it just used a made-up group ID of 1,000,001. It just assigned that to the Windows users here. Well, so yeah, with users, it said I couldn't find a group name for that in Windows, so I just assigned it 1,000,001. But it does recognise that this is Martin, the identity here. And of course, like we saw before, so we now see how the identifiers were formed, but notice how the permissions are a synthetic ACL. The ACL's not real, there's real Unix permissions there. If we say show me the, I typed correctly. If I say show me the user ID for that file, notice that is 2003. So notice how it has found the user ID for Martin. That's come straight from OpenLDAP. So on the Unix side, it is using, like the diagram, it is using the UID and the group ID from the Unix side. If we look at the Windows side again, look at these files. I knew this would happen, too many windows open. They've shut down, which is a handy feature of the unlicensed version. I'll go into how we can see within OneFS how this has happened. So we actually see exactly what's going on. And I'll also show you examples that are not for a multi-protocol user, when this kind of goes wrong in a way for our other accounts. Come on. So we'll send a Control-Delete. Let's log back in as Martin, who had the files. If we log in as Martin here, and then we go back. I have a slight issue here while these services start up. Let's disconnect while that's starting up. Let's map the drive again. Let's be consistent with the names. Called i/cluster/ifs. We're having domain services haven't started yet, which is probably more of a case that on the cluster it's not very happy. Seems to think it's online now. There we go, so the services are up and running again. If we look at file.win, as we said, this is going to look completely normal. If we look at file.nix, which is one that shouldn't look normal, this is where it says, hey, I'm resolving this to the SID that Windows expects. It's lost the window. Underneath I can see my real user ID here. That'll be important in a second. On file.win, so I can see underneath that is the real. if you can read really, really quickly. So we've seen the group ID. I'll explain what's going on there in a second. I'm going to have to show how that's generated. Okay, so notice there that it hasn't actually used that SID at all for the user. So under that Windows file, it's using the UID 2003. There is no SID there for the user, which is a little strange. This is because of this preference towards using UIDs over SIDs. For Martin Multiprotocol, it's made that choice of I'd rather use the UID, and it does that in OneFS by default for performance reasons. It has a slight preference towards using UIDs. Before we go into more detail on why it's doing that, let's look at the access token for the cluster here. Auth. Mapping token. For Martin, he'll be Isilon MP. Needs to escape the slash. Martin. You can see that in this output, it's saying, okay, if I look at the Windows user Martin, it's seen that the UID for this user is 2003, which we know is correct from LDAP. So it's taken that from LDAP, it's not stored in AD. If I look at Martin there, I can see that is the correct. So it does know Martin's. Put this on the screen at the same time. It's the confusing part of having too many windows open that aren't all real. There we go. Excuse me. If you compare those two, so this is Martin's real SID on the Windows client versus Martin's SID according to OneFS, exactly the same. It's matched them based on username. So it's matched up their usernames and said they are the same person. It also knows, though, this is part of the user mapping process, it's put together the IDs that ID Mapper mapped. It said when I gave you this UID, I found this matching SID and vice versa. There's other things here like the primary group, which of course the primary group here is Isilon MP domain users. This is where it couldn't find a matching name within LDAP for domain users. So it made up the GID there. It allocated, 1,000,001. Of course, because it came from Windows, there is a real SID for that group, which is what we'd expect. And on disk, it's going to use the SID, which also, this is where it's saying if I write this group on disk, I'm going to use the SID, which again makes sense because that's the real one. The other one is just made up to map to this SID. There's other identities. So of course, we saw the users group came from LDAP. So this is a group that Martin's a member of, and the group ID for that is 1545. Notice down here that the SID is based on that. So it's given it a 1532545 for that group. There's another group, authenticated users, which again, the SID based on the, sorry, that's a real SID, excuse me. If I now do the same thing for a Windows-only user, we'll see some slight differences. So this is where this kind of probably makes sense. Just to talk about the on-disk identity here, this is a setting that OneFS has chosen for when it's to determine when Martin writes a file. It's saying, I will write the identity. Oops. So if Martin writes a file, by default it says, okay, if I have to, I will always try to use the UID if Martin comes in from Windows, it'll say, I know Martin's underlying SID. I'll map that to his UID and write that, which is why if we look at that file, the Windows file, notice here how the user ID is 2003. There's no reference here to the SID as the owner for Martin, because the setting here is saying, I think you should use the UID instead of the SID. So there's an automatic preference that is coming from this on-disk setting. I'll talk about how it determines that in a second, but it determines that. It has a preference list for that. And of course, this is where it has a slight preference to UIDs because of the performance underneath would be quicker by doing this. To show you a different user, let's log out now as Martin Multiprotocol, and we'll log in as somebody else. So we'll sign out as Martin. Let's send a Control-Alt-Delete. Let's log in as William Windows. And the big difference here, as I demonstrated before, is that William doesn't have an account within LDAP. He is purely a Windows user. So now if I go into my map network drive, if I go into data, let's make a new file. So William's written a file. Again, I can demonstrate here that if I go to properties, looks pretty normal from a Windows client point of view. If we go into the command line again, and I know it's kind of obvious because of the name of the directory, but who am I? You're William. If we look at the SID again, I can see there's an SID there. One thing we do know is William doesn't have a UID, not a real one, in this environment because he's not a Unix user. So, of course, the demonstration is, so what does the system do? I can still see William's file. I can't log in as William directly, but of course I can look at his file as Martin if I can type it. So notice I can see William's file. I'm not William, I'm Martin, but so that's William's file there. Notice here how it can't resolve Martin's, sorry, not Martin's, William's UID to a name. The reason for that, because it doesn't have one in LDAP. So Unix is saying, I don't know the username for user ID 1,000,001. And of course there, notice the 1,000,001, that is an allocated user ID. We can already see here that it would fail to find William within LDAP. We know it won't do that. If we then look at our resolution list here, so what it's done is to say, I can find William within, so I know William's SID when we went in because he's a Windows user. The next step, can I find him in AD? Yes, I can, but when I look in AD, I'm not using services for Unix or IDMU. So, doesn't find him. Doesn't find a user ID against that user. It then checks the ID mapping database, doesn't find anything there. Not the first time it sees a user. The next thing it will do is to look through, in our case, it will look through LDAP. Why? Because that's the provider we're using. Won't find anybody anywhere else. I haven't put anyone in local or file or NIS. So it looks in LDAP, doesn't find him. We know it won't. He doesn't have an account. So the next thing it does is to say, I've tried every option. Going to have to allocate the first available UID, which in William's case was 1,000,001. Someone's already been given 1 million for their UID. He's been given 1,000,001, and we can see that in that allocation there. If we go to the cluster and look at William's file, oh, well, firstly, I can just do a normal listing on there for Williams, just like before, just like the Linux client. The only difference here is notice how OneFS does know who William is. Just because it knows how to map 1,000,001, it understands is not a normal Unix user. It understands that this is actually Isilon NP William. So it can resolve William's username because it happens to know that William is a Windows user. Also over here, notice how it knows that that group is domain users. So again, it can resolve that given group ID of 1,000,001. It knows that that's been given to Isilon domain users. Notice how this looks a bit odd because they're the same. Doesn't matter though because they're two different values. So just the fact they match up, pure coincidence. Who cares? It doesn't make any difference. So the fact they're both 1,000,001, it wouldn't matter if they're completely different numbers or the same. If I just leave it resolving that to, so let's show the actual permissions. Oops, helps if you leave a space in there. It's just saying here, okay, so these are the real permissions. They're coming from Windows. Notice the plus here is indicating this is coming from an ACL, and then I'm making the Unix permissions from the ACL. And we know that's going to happen because this is very much a file, like file.nix, file.win, excuse me. We wrote it in Windows. It was written by a Windows user. Okay. If we now say to the cluster, could you show me William? Actually, let me get everything else off the screen first. I'll do it again. Yeah, we can see the username is William. So when it assembled the access token, this is slightly different because it said, I never did find a UID this time. I made one up and I added that to the database because I couldn't find William in LDAP or any other services. The SID there is real, and again, if I compare that to the SID over here, helps if I click the right window. Let's get rid of this one behind. Notice they are the same. Easiest bit to look at the last little pieces there, the 1107, that's a real SID. Notice how this time round, something slightly interesting that's happened is the on-disk ID is the SID. That's the only real ID that that OneFS found. So it got that preference of, I'm allocating a UID, I don't want to put that as the identity on disk. I'd rather use the SID as the user's identity. So this time around it's slightly different. It's actually writing the SID. Should be able to see under William's file. So notice here it has mapped the domain group in there. If I look at the numerics for that, you can see, yeah, the owner there, it's actually coming from the, on disk, it's the SID. Notice how it doesn't look like that because it's got 1,000,001, but don't forget these permissions here aren't real. They're being generated from the Unix permissions are coming from the Windows permissions translation. The real permissions are these underneath, which are using William's SID. The preference is because William is only a Windows user. Yeah, so if I do it this way around, you can see here it's saying, okay, if I see that SID, I know that maps to UID 1001. That was where the ID mapper wrote that, and it said, I'm going to stick that into my database so I remember next time that's permanently assigned to William in this case. So William is permanently going to be UID 1001. If I do this the other way round, it should be less typing because I need to put in the UID 146. If I look the other way around, it says, oh yeah, I've got another mapping here. These are two separate mappings where it's saying the other way around, I know that 1001 maps to this SID. So these are two separate records for William. They're associating him with user ID 1001. Now we're going to change this slightly. Let's log in as Larry Linux. Let's make a file here called touch Larry's file. Again, if we look at that, looks completely normal. It's Larry's file. If I do an ls minus ln on Larry, so I can see the underlying UID for Larry's 2000. Its group ID for the group users is 100. So notice underneath here I've got Larry's 2000, users is 100. If I try to look at the file in Windows, of course I can't log in as Larry. We're now the other way around. Larry doesn't have a SID because, going back to the board on there, Larry is not part of AD, doesn't have an account within AD. Don't want to open it, I want to look at the properties. So here I'm logged in as Martin again, and if I look at Larry's file, notice here I get this, it was only there briefly, but you may have noticed there that the SID was based on an allocated, it used a Unix SID basically is what I'm trying to say. As it used a Unix SID there, the SID it had was based on the Unix identity of Larry because it doesn't have anything else. There is no Windows identity for Larry. And notice here how it's now showing was LDAP users Larry. The group's got a different name because it recognizes, well, this came from LDAP. It came from the users group. So I can see the file from Windows. Larry can't because Larry can't log into Windows. Just as William can't log in through Unix. If I then go to cluster and I do, I'm in the right directory still. Oh no, not Larry. We don't Larry, sorry. Again, looks the same. If I say show me the real permissions, real permissions on that file. Notice underneath there it's saying, yeah, Larry, there is no plus here, which is indicating to me this is a synthetic ACL. There's no plus edge, shows a real ACL. Also notice it does tell you, I'm going to show you the synthetic ACL. The user is Larry, part of the users group. It doesn't have any Windows identity for Larry because where would it get it from? Doesn't know. If I do this as a numeric, just to show that point, notice how it's only got user ID and group ID in there. So user ID is 2000 for Larry, group ID is 100. If I just show that, I should have done that here. You can see Larry is user ID 2000. Just to show that. And part 100. So this is matching Linux. It looks the same, which is what we'd expect. You know, this is how the compatibility works. If I then say on the cluster, okay, let's have a look at Larry's. No, let's not do that. Easy auth mapping token for Larry. Notice here how it does have an SID for Larry, which we just very briefly saw in Windows before it resolved it, which is 122.1.2000 is, of course, Larry's UID, which you can see directly above. This is where it's formed a Unix SID because it couldn't find a Windows identity for Larry this time around. Underneath, of course, the group there, primary group, is coming straight from LDAP. Group ID is 100. Again, notice how the SID here for that group is based on the group ID. So that's another Unix SID. If we then look, in the database, 4213. Notice there Larry is in the database, but it's only it doesn't need to store that association with the Unix SID because it already knows I made this up. You know, it's not a standard format. So if I try this the other way round, for S1 22.1 2000, yeah, it just says this maps to user ID 2000. Also notice if I go, let me clear that. If I look at Larry's token, notice how the on-disk identity is the UID, and you think, well, of course it is. That's the only identity that's known for Larry that hasn't been made up or mapped to him. So we know that is the exact UID is now going to be used as the on-disk identity. Okay. So there are a few other things going on here. So the more advanced side, we've covered the basics of this, but there are some more advanced things going on. Okay, so if I can have rules of how permissions are, ACL policies control how permissions are translated. And this is where I've heard a few students in a few different classes who get frustrated where they say, okay, I don't like the way it translates permissions. I don't like it that when I go to access a file and I set that file as, with a chmod as fully open, when that's translated from POSIX mode bits, so for the owner group, other, that will by default translate to all read, all write, all execute permissions, which makes sense because you're saying that's literally all the read permissions, all the write, all the execute for everybody. That's what it will do for that user. Some people say no, I see it's fully open in a Unix system, should be fully open in Windows too. And of course in Windows, full control will give you things like take ownership and a few other extra options that you have, extra permissions. So ACL policies can change this. If I look at Larry's file, Okay, so if we look at Larry's file, you see here we have these permissions. Let's fully open them up. It's Larry's files. He's allowed to fully open them. So now they're fully open. Let's look at them through Windows. If I go to my Windows client, and if I look at Larry's file now, I'll see that, yeah, we've got all read, all write permissions on there for Larry. If I don't want that, if I do want it to give full control, I can edit the ACL policy to change that. All right, got that in the end. Okay, so it's complaining about the usual security thing there. If I go to my ACL policies, this is where I can see these subtle settings that are controlling how the permissions are translated. So underneath, I've got several. I'm not going to explain all of them. There's a lot. There's several things there. They all do different things. It will subtly change how permissions are translated or how permissions are used or controlled. Yeah, at the moment, it's on the default here for. If I scroll through them, you'll see here there's the retain, read, write, execute permissions. Let's do it the same as Unix. I might say, no, I don't like that. I want to change the way permissions are translated. I want read, write, execute to mean full control. I can then save that, allow that to apply. If I go back to my Windows client, I'm on my Windows client already. Now if I look at Larry's file, notice how now Larry's got full control listed for Larry in his permissions. So this is where customers can make subtle changes. It's often a case of it can look like a bug or a problem where I have a certain expectation of how files should look, like here, and it's not translating the way that I thought it should do. So that's the kind of thing we can do with ACL policies. They just control how the permissions are translated. We've seen already the on-disk ID, so how it selects that underneath, so there is some control over that. Native is the default for the way it selects that, and that's basically trying to have it's trying to have a slight preference for if Windows writes a file, you do it the Windows way. If Unix does it, you do it the Unix way. But you did notice in the demonstration that it has a slight preference towards if I can use a UID, I will use UID. So the only time we've seen it in the demonstration where the on-disk ID was an SID was for William, because William only has an SID that's real. William is purely a Windows user. So that's another setting on there. That can be controlled where you can say, I don't care whether you're a Windows or a Unix user. I think the on-disk ID should be Unix, which will be, I'll show you the setting briefly here. I can control that. The reason I might want to do that could be for performance. Native will generally work pretty well in most cases, but if I wanted to, I could also change that. I'll leave the browser running. Oh, excuse me. Of course, you're familiar with the presets here for ACL policies for preference. Where will I find this? Down here. So notice here I've got the on-disk identity. Native just means have a slight preference, as we said, towards if you come from Windows, I have a slight preference for I should use your SID unless I can find a real UID. If you come from Unix world, I'll use your UID. Of course, I could say here, I don't care which you come from. I want you to use the UID. Or opposite, I could say I want to use the SID. Excuse me. So the next problem that can happen would be, what if I've got two users who are the same person, but for different reasons, like maybe two organizations merged, one used Linux, one used Windows, and now I just happen to have a user who's there where their username is not the same. And of course, by default, OneFS is expecting to see matching usernames. So let's do this here. If we go into our Windows client, and then we go into our Linux server. And let's create a user here. Generic user account, so that'll be for Unix. Got moniker, merged user. And let's call Monica on our Unix side where she came from. Let's just say that Monica's username was Monica. Let's say Monica M. So now we have Monica here. And then if I go to my Windows server, let's create Monica an account that she has in another organization. Maybe they're standardized and very strict on creating their accounts in a certain way. Okay, so let's make her an account. Monica merge user. Let's call her Monica instead of just double check it. We'll call her Monica. Oh, no, sorry, I called her Monica with a capital M there. Let's call something slightly different in Windows. Let's say they're very strict in this company on using surnames only. It'd be daft, but M merged user. For some reason, completely strict on that. And we know this is the same person, but now two completely different account names within AD and LDAP. We can use user mapping roles to control that. So user mapping rules are how the access token gets formed. So we do our user mapping stage of let's put all our identities together into the access token. User mapping rules can finally control how that's put together. So exactly how it's put together. What we're going to do is create a rule that says when you see this particular user in LDAP, you'll map that particular user to this user in Active Directory. So we're going to tell OneFS to do that using a user mapping rule. Let's do that in our Windows client because we already have a browser open. And what we'll do is go to, where am I looking? Rims and roles. Our user mapping rules are here. Don't have any at the moment, which is standard. By default, there wouldn't be any there. If I want to add a user mapping rule, I've got different operations. I can do things like take information from one user account and place it in another, like groups, things like that. But in this case, we don't want to do that. We want to join two users together and tell the system this is the same user. I have to tell it which provider we're talking about. So let's start with LDAP. And there's Monica there. And then on the Active Directory side, not many users here, so let's just look for her. There we go. Notice that I could say if it doesn't work, fail anyway. Let's add this change in place. Okay. And now if I log into the Linux client, Monica M. See. See the files there. Let's make a. Just getting a lot of files there. Notice here how at the moment it does seem to be working from the normally from the Linux side. If I do ls ln on Monica file, so 2006, all fine. That is her user ID. If I then go into Windows, shall I do some Windows client? Get rid of that window. And now let's log off. This will be Monica multi merged user, I think the name was. Nope, hold on a second, what was her username? Merged user. This is a lesson in using difficult to remember account names. There we go. Let's map that network drive. Look at that. Notice how it's using an on-disk ID for the LDAP user 2006. See how it recognizes that as my file? Let me change it. My permission there, not everyone can. I can because it knows who I am. If I write a file here, Windows, permissions will look the same. So notice there it's using my SID. Now if I go into the cluster to see what's going on, you can see there they both come up as me, or not as me, as Monica. I can see underneath the real permissions. Let me just do it on one file, sorry. Let me do this one at a time. Let's try Linux first. Oh, sorry, it's because Monica's file. And if I do the same thing for so see how they come up as the same identity underneath. This is because I've created that mapping rule that's telling the system I'm the same person. That shouldn't really work because this user has a completely different username, but that's how a customer could fix a problem like that, particularly if this problem is only for a finite number of users, not for everybody. There's no point in creating a rule for everybody, and you know, if you have hundreds of users where this works perfectly, you don't want to break it over one user. Yeah, it recognises I'm the same person. If I do an Isiauth token, Isiauth mapping token minus user. Excuse me. Let's do that into a more, as there's quite a lot of information coming through. So you see the user Monica there, UID 2006. On disk ID is 2006. So using the UID. If I do this the other way round and ask for Isilon MP slash Monica merged user. Oh. Again, should have learnt my lesson, but I haven't. So I can see my user, which I need to see to work out who I am, merge user. Notice my SID, when I look at this way around, doesn't come from that user. MM merged user. So you can see here it's joined my accounts together. So each time I'm logging in, effectively it's giving me my Unix identity each time. So I'm forcing this to work by forcing it to recognize my Unix identity. Notice in my supplemental identities, it does know my real SID. It's just not using it as an on-disk ID. So on-disk is using the Unix identity, but notice underneath it says, oh, by the way, you are also 1521 So it does know that's the same person, but that's a real-world problem that can be fixed using this. The next concept here really is access zones. Thus far I've only been using the system access zone, which is the default. This is making the cluster behave like, in a Windows view of the world, it's like I have a single Windows server. And of course, the problem with doing that is if I have a single Windows server, let's imagine you have a customer, they have a very, very scalable big Windows server, and then they say, I have 2 untrusted domains and a single Windows server. Can I securely use it across both domains? And the answer is no. Why don't you use one server for one domain, one server for the other? This is why we'd need access zones. Inside an access zone, we have authentication providers, which we allocate. We have shares and exports, which we allocate. Because they support NFS or SMB in newer versions. And the last thing we put inside an access zone is the IP pool. Although we haven't really been talking about networking, of course, on the Isilon, you always have to come in through an IP pool. It's how it allocates the IP addresses. There is no choice. If you're using Smart Connect, you might call that the zone name, but it is the pool of IP addresses that you're assigning to that particular access zone. So when you come in through the IP pool, this is what you would perceive as an end user as being the server name. So the IP pool would have a name like //cluster/ that will be the IP pool, and of course up here would then have the data that you're going to be shown would be the could be the share name up here. So to an end user, they're going to perceive the IP pool as a server. If you use everything within the system access zone, the default, it's like having one big Windows server. It doesn't matter if you give it several names, you're going to see the same data inside of it. It's one server. When you log in, you have to come through an IP pool. Of course, this will tell us how to authenticate as well. So we can subdivide different domains to be used by different authentication providers on this. So I can use one Isilon cluster and use it as 2 different Windows servers, one for one untrusted domain, one for a different untrusted domain. And it would allow me to do that. So it allows me to have secure multi-tenancy in the cluster. So if I draw this out as a kind of real-world example, we've been using a domain isilonmp.com. Let's imagine, well, so far I haven't been using access zones, so I have effectively one big Windows server. Let's imagine another team want to use a cluster for secure medical data. They have a different domain. Let's call them SecMed department on there. And they've asked me, can we use our single cluster for both of these untrusted domains? The answer there would normally be no. If I leave them both without an access zone, this would be very, very bad for security. I could rely on permissions, but permissions can go wrong. So this would be a very, very bad thing. what I could do here is create two different access zones. So to make this more secure, I could make an access zone for this domain. And an access zone for this domain. What I could then do is place my, because I'm placing these into these different domains, I'd then use a different IP pool for each. And of course, I've got authentication providers here. I'll put different data in here, shares for each of these two customers. I have a different IP pool here. And have different shares here. And the idea is I could subdivide my cluster to make it look like two discrete servers. This is not the only thing you can divide as well. So you're dividing authentication providers, you're dividing your data. To the outside world, this would appear like two completely separate file servers. On top of that, there's certain other settings. So I get different local provider for each of these. Notice how my user mapping rules yeah, that's fine. If I go here into my, well, firstly, notice my ACL policies. I can't set those per access zone. That's a global setting. But if I look at my user mapping rules, notice how that is per access zone above. So I can have different user mapping rules if I want to between my different domains. Yeah, so I can control that as well.